Let's explore Greibach Normal Form, often abbreviated as GNF. This is a standardized form for context-free grammars where every production starts with a terminal symbol. A context-free grammar, or CFG, is said to be in Greibach Normal Form if every production rule is in a specific format. This format is represented as a derives a alpha. Let's break down what this means in detail. In the expression A derives a alpha, A represents a terminal symbol. This means that the first symbol in the production must be a terminal. Alpha represents a string of non-terminals, also known as variables. This means alpha can be any combination of variables, but it cannot contain any terminals. So the key takeaway is that in Greibach Normal Form, every production must start with a terminal symbol, followed by 0 or more non-terminal symbols. Let's look at some examples to see the Greibach Normal Form in action. On the left, we have valid Greibach Normal Form. Notice that each production rule starts with a terminal symbol. For instance, in S derives AAB, A is a terminal. Similarly, A derives BB starts with the terminal B, and B derives C starts with the terminal C. This follows the Greibach Normal Form. On the right, we have a grammar that does not adhere to the Greibach Normal Form. Notice that the production S derives AB begins with non-terminals A and B, and not a terminal. The other productions A derives AB and B derives B are in the correct form because they each begin with a terminal. Therefore, the grammar on the right as a whole is not in Greibach Normal Form. Before converting any context-free grammar to Greibach Normal Form, there are a few steps to follow. First, eliminate epsilon productions. This means removing any null productions from the grammar. Second, eliminate left recursion. This involves removing both direct and indirect left recursion from the grammar. Finally, apply the Greibach Normal Form transformation to put the grammar into the required form. The first step in converting to Greibach Normal Form is to eliminate epsilon productions. On the left is the grammar before the conversion. Notice the production A derives C or epsilon, where epsilon is a null production. To eliminate this, we remove the epsilon production and replace it with new productions. On the right is the grammar after removing the epsilon production. We've removed the A derives epsilon production and added the production S derives AB. This ensures that the grammar no longer has any epsilon productions, completing the first step in the conversion process. The next step is to eliminate left recursion. On the left, we have grammar rules that exhibit left recursion. For example, A derives A alpha or beta, where A derives A plus B or C. To eliminate this left recursion, we transform the grammar into the rules on the right. After eliminating left recursion, we have A derives beta a prime, and A prime derives alpha a prime or epsilon. Applying this transformation to the example, we have A derives C a prime, and A prime derives plus B a prime or epsilon. This ensures that the grammar no longer has left recursion. Now that we have eliminated epsilon productions and left recursion, we can apply the Greibach Normal Form transformation. On the left, we have the grammar after eliminating left recursion. Here, the production rules are S derives AB, A derives AB or C, and B derives B A or D. The final Greibach Normal Form is on the right. Notice that each production now starts with a terminal symbol. For example, S derives ABB or CB, A derives AB or C, and B derives B A or D. Highlighted terminal symbols indicate that these productions now adhere to the Greibach Normal Form, where each production begins with a terminal symbol. If you like this video, hit that like button and don't forget to subscribe. Visit CodeLucky.com for more such useful content.